All right, here's another example. Here we have three unknowns and we have three equations just like before. What's different here are all these zeros. So this is called homogeneous. All right, and did I spell that right? Homogeneous or homogeneous? No, yeah, homogeneous. All right. So this is a homogeneous system, and if you stop and think about this, each of these are planes, and they go through the origin. Right. So if x, y, and z are all 0, that works. If x, y, and z are all 0, that works. If x, y, and z are all 0, that works. So there's at least one solution, and that's x equals 0, y equals 0, z equals 0. Now there might be more. They might intersect at a line, right? The line itself might also go through the origin. So we have to keep going here and figure this out. So this is 1, 1, 1, 1, 2, 3, 1, 3, 5, 0, 0, 0. Let's start. We need this to be equal to 1. It is. Good. We need this to be equal to 0. It's not. So we'll take row 2 minus row 1. And we can actually do this a little faster because we know this is also going to be 0. So we can also do row 3 minus row 1. So row 1 doesn't change, but row 2 does. 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, 0 minus 0 is 0. 1 minus 1 is 0, 3 minus 1 is 2, 5 minus 1 is 4, 0 minus 0 is 0. The next step is to get this equal to 1. It is. Great. Let's make this equal to 0. And we can do that by taking row 3 minus 2 times row 2. So row 1 doesn't change, and row 2 doesn't change either. Row 3, you have 0 minus 0, you have 2 minus 2, you have 4 minus 4, that's a 0, equals 0. Now if you've been paying attention, you might look at this and say, whoa, is this a contradiction? No, it's not. All right, so this is okay. What this means is 0x plus 0y plus 0z equals 0. And yes, it does. So this is okay. This is essentially going to tell us that the system's not inconsistent, but we're going to end up with our solutions being on a line. What next? Let's make this equal to 0. All right, so we'll take row 1 minus row 2. So the second row doesn't change, the third row doesn't change. Top row is 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is minus 1. 0 minus 0 is whatever. All right. And here we can actually, or we have to stop. We can't make these into zeros. We don't have the one to do it. What this means is x minus z equals 0, and y plus 2z is 0. And so this is, we parameterize again. So the idea is to say, we're going to have x equals, hold on here, x equals, y equals, z equals t. So y is going to equal minus 2t, and so x is going to equal t as well. Now notice there are no y-intercepts. Why not? Because the three planes go through the origin. and they also happen to mutually intersect along this line that also goes through the origin. All right? Goes through origin. So a homogeneous system of equations always has at least one solution. The question is, does it have an infinite number of solutions? This one does. It has an infinite number of solutions, all of which lie on this line here. So you could put in any value of t, you'll get a triple, x, y, z. That will be a solution to our system.